Hi everyone. In today's lesson, we're going to talk about graphs of ellipses. By definition, an ellipse is the set of all points P in a plane such that the sum of the distances P from two fixed points in the plane is constant. That's the textbook definition. Basically, what this means is that we are going to be able to create a more of an oval shape rather than a circle. So take a look at this oval looking shape. Obviously, this distance here is a little bit larger than this distance here, creating that oval. This usually occurs, this is called a cross section of a cone, and this cross section of the cone will create this ellipse type figure. So our equation, when we have a center at the origin, it's always x squared and y squared. And when we have a center not at the origin, it's just like the circle, x minus h squared, y minus k squared. Now we've got these fractions. They're always going to be divided by an a squared value and a b squared value. And there's always going to be a plus sign, and there's always going to be a 1. So let's define what each of the parts are. So A is always the larger number, and it's the distance from the center to either vertex. B is always the smaller number, and is the distance from the center to either covertex. And C is the distance from the center to either of the foci. And I'll explain what all that means. I think the best way to do this is just through an example. So take a look at this equation. We've got x squared over 25 plus y squared over 16 equals 1. So you see on the denominator that there are two numbers. The 25 is the bigger number. So a is always the larger number. And in the formula, it's a squared. So you want to ask yourself, what thing squared gives me 25? So you should be saying 5. So a is always the square root of the bigger number. Then b is the square root of the smaller number. So the square root of 16 is 4. Now, if the larger number comes first, then we have a horizontal major axis. So you see how the larger number 25 comes first? That way we're going to circle horizontal axis. Why? Because the larger number comes first. Here 25 comes first and it's bigger than 16. The center is just like a circle. So here I have x squared, y squared. So the center here is just 0, 0. Now, vertices are on the major axis, and those are the a values. The covertices are on the minor axis, and these are the b values. So I want you to think vertices a, covertices b. So first I'm going to plot the center. So the center is 0, 0. And since we know that this is a horizontal major axis, we know it's going to look like an oval like this, opening horizontally. So A is always the distance from the center to either vertex. So A, since it's 5, we're going to go to the right 5 and left 5. So here and here. And these spots are called my vertices. So I'll put V's there for vertices. B is the distance for the center to the covertice, right? B is the distance from the center to the covertice. So the covertice, I'm going to put CV, is up here and down here. So we're going to go up 4, since that's what B is, and we're going to go down 4, since that's what B is. And all we have to do now is just connect this. And here is my oval looking shape, or my ellipse. So here they're asking for the coordinates of the vertices. So the vertices are here at the endpoints on the major axis. So vertices, we can call that a vertex here and a vertex here. And up here we can call these covertex and covertex. So the coordinates of the vertices are 5, 0 and negative 5, 0. So we can put that here. And the covertices are these spots here, so 0, 4 and 0, negative 4. Now they want to know the length of the major axis. Well, the major axis is where the vertices are. So here is your major axis. What is that distance? Well, from here to here is 5, and from here to here is 5. So that major axis length is 10. And you can put here vertices or vertex, right? That would be our distance. And our minor axis are my covertex distance. So my co-vertices would be the distance from here to here, right? So this would be 4, this would be another 4, which would give us a total distance of 8. And then the last thing that we need to do is find the coordinates of those foci. So there was a formula here that I used for that. Here is c squared equals a squared minus b squared. So the formula will help us find the c. So c squared equals a squared. Well, a is 5, so 5 squared is 25. B squared is 4, or b is 4, sorry. B squared is 16. So we can subtract those and get 9 and take the square root. So c is 3. So all we're going to do now is go 3 from the center. We can label this with a foci, and 3 from the center the other way, foci. And those coordinates are -3, 0 and 3, 0. All right, let's jump to the back page and take a look at a ellipse that has a vertical major axis. So we have a vertical major axis when the ellipse looks like this, right? When it looks more vertical than horizontal. The major axis is still bigger, but this time it's up and down instead of left and right. So we still have our center at the origin when it looks like this, and we still have our center not at the origin when it looks like that. Notice we still have a plus and a 1. That always changes, that always stays the same. Now what you should notice that's different is that the b squared now is going to come first. Remember that the b squared is the smaller number and the a squared is the larger number. So remember now, if the smaller number is coming first, just like it is here and here, then we have a vertical major ellipse. So let's just take a look at an example. So here we've got example number 2. As we can notice, the smaller number comes first and the second number, or the larger number, comes second. So we know that a is the square root of the larger number and b is the square root of the smaller number. So the square root of 25 is 5 and the square root of 9 is 3. And we know this is a vertical major axis because the smaller number comes first. Now the center we read just like a circle. So if this is -3, we flip the sign. So this is +3. If this is a +2, we flip the sign and it's a -2. So let's go ahead and label what we have so far. My center is at 3, -2. So I'm going to go ahead and plot that point, label it with center. And we know that the A still is the major axis. This time it's vertical. So we're going to draw our picture this way. Now nothing really changes much. The vertices are still on that major axis, right? This is the longer side. The major axis is the longer side. The minor axis is the smaller side, and these are our co-vertices. So if we're looking for our vertices, we have to look at the A value. If we want the co-vertices, we look at the B value. So A is the larger number, A is 5. So this time we're going to go up and down 5. So we're going to go from the center, we're going to go up 5, and then we're going to go down 5. We can go ahead and label this with V and V for vertices. And while we're here, we might as well name those points. This point here is 3, 3, and this point here is 3, -7. So 3, 3, and 3, -7. All right, so now my smaller value, my B value, will give me my co-vertices. So my B value is 3. So we're going to go over 3, and we're going to go left 3. I might as well name these points. Here are my co-vertices. So this point here is 0, -2. And this point here is 6, -2. And we can connect. Hopefully your picture looks a little bit better than mine, but that is your vertical ellipse. So we can keep going. The length of the major axis is the distance from vertice to vertice. So here is a distance of 5 and 5. We add together, that gives me 10. And the minor axis is the distance on the co-vertices. So this distance from here to here is 3. Another 3 makes 9. And the formula for our foci are c squared equals a squared minus b squared. So the a is squared is 25 and the b squared is 9. So 25 minus 9 should give us 16. And when we take the square root, we get 4. So the foci lie on the major axis. So this time here, we're going to go up 4, down 4, and put our foci. So up 4 would be here. We could call that foci 1. And down 4 will be here, and we'll call this foci 2. So those coordinates here, this one is 3, 1, and this one is 3, negative 6. All right, that's it. We've completed 2 examples. We've done one ellipse with a horizontal axis and one with a vertical axis. So if you have any questions, now's a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.